Hi everyone, welcome to our series of seminars on various technological advances. If you have not yet subscribed, make sure to click the subscribe button. Today, let's add some knowledge on conversion of thermofuel from plastics. So, in this video presentation, I'll be discussing about the scope of the project, followed by a brief introduction. I will also be explaining the process, selection of plastics, and how a small-scale setup can accomplish this task. I will also be talking about its advantages, opposition faced, and various waste-to-energy plants around the world, and end with a conclusion. To begin with, let me explain why this technology is very much important for the present scenario. It aims to solve major twin environmental issues, namely the pollution due to plastic waste accumulation and the need for an alternative fuel source. So, how do we keep up with the changing times and requirements? The most suitable answer would be doing what we do best, adapting and evolving to meet the standards and grow. Now, before we dive into the topic, let's just get a brief idea on this theme. And to begin with, what are plastics? They are a wide range of synthetic or semi-synthetic materials with a few examples being hdpe, ldpe and PET that usually is a product of polymerization. The plasticity during production enables them to be molded, extruded and pressed into solid objects of various shapes. Now that we have an idea about the input content of the project, let's look into the final output. That's the fuel. Fuel is a substance that produces useful energy when it undergoes a chemical or nuclear reaction. While wood, coal and oil are fuels that undergo burning to provide heat or power, plutonium is a source of nuclear energy. Waste to fuel as a broad category has been under constant research to utilize the energy from waste material to reduce the impact of wastes accumulated on the planet. It's a form of energy recovery that produces energy through combustion of waste or by producing a combustible fuel commodity. So the process that we use to convert plastic into fuel involves pyrolysis as a major step. It is a thermal decomposition of materials at elevated temperatures in an inert atmosphere. It involves change of chemical composition and is mainly used for treatment of organic materials. To begin with, the selection of waste plastic is very much crucial to obtain optimum fuel properties. The total waste plastic generated when categorized into different subdivisions is visualized in the pie chart, with ldpe and hdpe being the major constituents. The selection of plastics to be converted into fuel can be studied and the result obtained is visualized as a bar with polystyrene exhibiting excellent fuel properties and followed by polyethylene and polypropylene. PVC, PET and polyurethane are considered not suitable and are avoided. Small-scale experimental setup can be conducted to get an idea on the process of conversion of plastics into fuel. A unit kilogram of waste plastics, preferably polyethylene, are cut into small pieces and dried before heating them within a reactor that is designed to withstand high temperature within 350 to 400 degrees Celsius. The burner is heated and when temperature rises to 150 degrees Celsius, the vapor starts to come down to condenser and the heating is continued for about 1.5 hours till the vapor stops collecting. Since plastic has been decomposed and broken down into smaller molecules, the use of catalyst is not required. And the top of the reactor is connected with a spiral condenser where vapors are condensed. Approximately 700 ml of thermofuel can be generated by this process per kilogram of waste plastic input. To understand the large-scale production, a flowchart has been visualized here. The plastic wastes are grinded and sent for melt feeding and then the process of pyrolysis takes place. Catalytic converter helps in the process and molecular rearranging of the polymers take place. The vapors are condensed with oil and accumulated in settling tanks and filtrated. Fuel is obtained after homogenization and can be used. Moving ahead, let's check out the advantages and opposition faced in this technology. The advantages are corrosion is less and a cheaper quality of fuel is obtained without the requirement of engine modification. there is much less amount of residue and large amount of product obtained. And the residue that is obtained also can be used as a paraffin wax. The opposition faced by plants adopting this technology is the concern that plastics may only get used once before conversion into fuel, and also may lead to decline in efforts to find alternatives for plastics and gasoline. Furthermore, fumes from the plants cause pollution and affect the local community. Electricity has always been the fuel for growth, which has been converted into solutions by innovation and creative problem solving. Ease of use helps the idea to thrive in the environment. To name few waste to energy plants around the world, I have selected Lee County Solid Waste Resource Facility located in Florida, Montgomery County Resource Recovery Facility located in Maryland, and the Burnaby Waste to Energy Facility located in Burnaby. To conclude, I would say that production of thermofuel from waste plastics is one of the best alternatives to get rid of municipal plastic waste while addressing the high demand for fuel. If you have found this video useful, please give us a thumbs up and don't forget to click the subscribe button. Thank you.